everyone, here is number 1, and we'll also do number 2 from the linear programming worksheet number 1. Okay, so we have the area of a parking lot is 600 square meters, a car requires 6 square meters, and a bus requires 30 square meters. The attendant can only handle a total of 60 vehicles per day. If a car is charged $2.50 per day and a bus is charged $7.50 per day, how many of each type of vehicle should be accepted to maximize daily income? Scale each axis by 5. I've gone ahead and scaled the axes by 5, which is what you see here. So the first thing we always want to do is define our variables, and they should always answer the question. Here our question is, how many of each type of vehicle should be accepted? So I'll say that X is the number of cars, and that Y will be the number of buses. Now we need to do our constraints, and our constraints are going to be a list of inequalities that we'll figure out what they are based upon our problem. But because we are in a real life situation, so to speak, that means everything needs to always stay in the first quadrant. So that means we need to restrict our X and our Y values to be positive, so that we won't be having negative cars or negative buses. So first things first, X will have to be greater than or equal to 0, and Y will need to be greater than or equal to 0. And we'll graph all of these in just a moment. Okay, now we know, let's see, we have a total of 60 vehicles per day. That's the max that we can have. So the number of cars, X, plus the number of buses, Y, needs to be less than or equal to 60. Also, we have the information about square meters. We can have up to 600 square meters can be used. A car requires 6, and a bus requires 30 square meters. So 6 square meters times the number of cars plus 30 square meters per bus, Y. The total square meters should be less than or equal to 600. Okay, so we need to have things that we are easily able to graph. First of all, this one's easy to graph, this one's easy to graph, but this one we need to rearrange a little bit. So if I solve this one for Y, I'll get Y is less than or equal to negative X plus 60. So we just subtracted the X over. So I'll be able to graph that one. And then as far as this one goes, a couple of steps. First of all, let's subtract over the 6X. So we have 30Y is less than or equal to negative 6X plus 600. Then when we divide everything by 30 to get Y by itself, we'll get Y is less than or equal to negative 1/5 X plus 20. Okay, so now we have 4 things that we are able to graph. So we have these constraints, and then the objective function down here, that's just going to be this part right here. We want to maximize the daily income. So we're looking for what combination of cars and buses will maximize our daily income. So our maximum income could be P equals, sometimes it's P, sometimes Q or R, it doesn't really matter, but usually you'll see P. P equals, we get $2.50 for each car and $7.50 for each bus. So 2.5 times the number of cars plus 7.5 times the number of buses will tell us our total income for that day. But before we can use our objective function, we need to graph the 4 constraints. So first of all, let's graph X is greater than or equal to 0. So here's the line X equals 0. It's a solid line because it's an equal to, greater than or equal to. So X is greater than or equal to 0 means we're going to be shading to the right-hand side of this. So instead of shading everything as I go, I'm actually just going to draw arrows pointing in the direction that I would shade. It makes the graph at the end easier to read if you don't have everything shaded everywhere. Okay, and now let's also do Y is greater than or equal to 0. So there's the line Y equals 0. And we're looking for greater than, so we're going to be shading above that. There's going to be little arrows pointing up. Okay, now for the next part. Y is less than or equal to negative X plus 60. So we're just going to graph the line negative X plus 60 like we normally would. So go to 60, and that's our Y-intercept. And then our slope is -1. Because we've scaled the axes in the same way, we don't actually have to count down little amounts of 1. We can count down by the units of squares here. So we go down 1 over 1. And so on, and then you'll connect these points like that. Okay, but we need to say which direction we would shade. We were going to choose the side where the y values are less than or equal to this line, so they're smaller below the line. So I'm just going to have arrows going below the line, pointing to the direction where the y values are smaller. Okay, and then we have one more. Y is less than or equal to -1/5 x plus 20. So our y-intercept is positive 20 here. And then our slope is -1/5, so we'll go down 1 over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and so on, and then connect those points like that, and then again put the arrows where y is less than the line, so that will be going down here. Okay, so looking at the arrows, we want to choose the part of the graph that is all pointing into the same part, and you'll notice this bottom corner here, this is all pointing into the same area, so our feasible region is all of this in here. Okay, so then our vertices, this is what we're going to use for our objective function. They're just the corners of our shaded region. So we have a few of those. We've got one right here, 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 and here. So let's just list those out off to the side. We've got 0, 0. We have 0, 20. We've got 50, 10. And then we have 60, 0. So now these are just a list of x and y values, x comma y values. So we'll just plug those x values and y values in one at a time for each pair into our function. So when we plug in 0 for x and 0 for y, p will equal 0. When we plug in 0 for x and 20 for y, we'll get 150. We plug in 50 for x and 10 for y, we'll get 200. And then when we plug in 60 for x and 0 for y, we'll get 150 again. Now we were looking to maximize our daily income, and each of these represent the amounts of income we would get given the number of cars and buses that we have listed off to the side here. So to maximize our income, we would want to pick the biggest number here, which is 200. So then that tells us our final answer means we would need to allow in 50 cars and 10 buses, that's just my x and my y, 10 buses to maximize my daily income. And that's my answer. Let's look at another example. Okay, number 2. A farmer has 50 acres for planting alfalfa and soybeans and has a maximum of $1,200 to spend on the planting. It costs $20 per acre to plant alfalfa and $30 per acre to plant soybeans. The profit per acre for alfalfa is $250 and for soybeans is $300. How many acres of each crop should the farmer plant in order to maximize his profit? Scale each axis by 5s. And again, I've already scaled our axis by 5s. First thing we want to do is define our variables, and the variables should answer the question, which here is how many acres of each crop should we plant. So I'll say that x is the number of acres of alfalfa, and that y is the number of acres of soybeans. Now for the list of constraints. Of course, the first two should be the least that we could plant of each type is 0, so x needs to be greater than or equal to 0, and y needs to be greater than or equal to 0. Okay, we know that we have 50 acres total for planting, so x plus y, the amount of acres of each one, the total should be less than or equal to 50. And then we know that we have a maximum of $1,200 to spend on the planting. Well, it costs $20 per acre of the alfalfa, and it costs $30 per acre of soybeans. So the amount of money that we spend on each of those combined should be less than or equal to $1,200. So we need to solve each of these for y if we can. The first two we don't have to worry about. Those are just single variables by themselves. But this one, we subtract x over to the other side, we'll get y is less than or equal to negative x plus 50. So that one's good to go. And then this one, again, we have a couple of steps. So we'll start out by subtracting the 20x. So we get 30y is less than or equal to negative 20x plus 1200. And then if we divide everything by 30, we'll get y is less than or equal to negative 2/3 x plus 40. So now we have four constraints. It's not that 4 is always the magical number, but in these two examples it's been 4. So let's start out by graphing the x is greater than or equal to 0 and the y is greater than or equal to 0. Okay, so that kind of looks the same from the last problem. Okay, let's graph the line negative x plus 50. So my y-intercept is at 50 and my slope is negative 1. Again, my axes are scaled in the same way, so I can just go by units or the little squares. So we're going down 1 over 1. And then we can connect those points. We're going to be shading below because we have y is less than or equal to this line, so the y values are smaller on this side. And then for the other one, my y-intercept is at positive 40, and my slope is negative 2/3, so we'll go down 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3, and then connect those points. And again, we have y is less than, so we'll be shading below that line. And just be careful, sometimes it won't always be less than, sometimes you'll have greater than. Okay, so then we're looking for the region that has all of the arrows pointing into the same part, and you'll notice it's this part right in here. So I'm just going to quickly shade that in. It's this part of our graph. And so then it's got four sides again, and my four vertices. We've got 1, 2, 3, and 4. Careful you don't go into that other part right there. We had to be below this line, so it's inside. So maybe if I sketch around it, you can see it a little bit better. 1, 2, 3, and 4. So it's in that region in there. Okay, so listing out my vertices. Oh, well, I need my objective function. I totally forgot about that. My objective function is going to be P equals. Okay, and that's, again, going to talk about maximizing our profit. So we make $250 for each acre of alfalfa, X, and we make $300 for each acre of soybeans, Y. Okay, now we can list out our vertices. So we have, the corners are 0, 0. We have 0, 40. We've got 30, 20, and then 50, 0. So again, these are just x and y values that we're going to plug into our objective function one at a time. When I plug in 0 for x and 0 for y, of course I'm going to make $0. If I plug in 0 for x and 40 for y, I'll make 12,000. If I plug in 30 for x and 20 for y, I'll get 13,500. And then if I plug in 50 for x and 0 for y, I'll get 12,500. So we're looking to maximize the profit, so we choose the largest one at 13,500. So that tells us that we need to plant 30 acres of alfalfa and then 20 acres of soybeans. So there's our answer. We've answered the question, how many of each type should we plant? And that's it. All right, if you have any questions, let me know, and I will see you later. Bye.